Okay. So this chapter covers these main topics here. Okay, you have to recognize the type of errors, how to trace errors, and how to use comments to locate bugs. Use just some common techniques, and tracing errors and debugging uses debugging tools, and how do you write code to respond to those errors. So I guess the more common or technical term for error is called exceptions. Okay, if you go into any language, you hear the term is an exception. Throw an exception or has an exception handling function and things like that. Okay, so here's a little story about computer bugs. I'm sure you heard of it before, right? About Grace Hopper and how she actually found out the bug, the actual moth inside the computer, and that would cause the computer to malfunction back in the 50s, 40s. And so that's how they got the term bug computer. But these are some general error types that you could encounter whether you're working on the front end or the back end type of programming language. Okay, usually the common one is the input of data, right? You read that input from either a browser or from a data file or from a database or from any other input. So you usually want to validate those input, make sure they would meet the criteria for a certain type. Another one is file not found. This is only for like a back end language where you can read files on the server itself. Like if you have taken the Visual Basic class, you probably had this experience before. So to read a file from your local machine, you can't find it, have an error, right? And of course, writing and reading to disk and so on. Okay, so let's go down here. The three main types of errors. You probably heard about these already. Syntax, runtime, and logic. I would say probably in that order in terms of the level of complexity or difficulty to debug. Okay, from syntax to runtime to logic, and this is the hardest one. Okay, because it doesn't give you any syntax error usually, and you get a really weird answer and you don't know why. Okay, so that's why it's the highest here. So the type 1 here is the syntax error. This is really low level, very easy usually. It could be difficult depending on what the syntax is, but usually it will tell you exactly what line it is, where is it at, what is the error, what maybe something that you mistyped or it doesn't match one of those keywords, right? So it will tell you that right away. And so here's an example of that. It would say a document write is not a function, but you say, wait a minute, it is a function, right? But because it's supposed to be a function, you were thinking about the write, because it's a write, this is a function, right? Function has parentheses. So the W here is capitalized, so therefore it's not part of the default or the DOM function. So that's why it's not a function. If that's not the case, then you have to write your own function with a big W, then that would have solved the problem. But because it's not part of the DOM, then it's an invalid function. Okay? Little things like that. It would be nice if you just say, you have a capital W, but it doesn't do that. So that's the syntax error. The other, another example here is a syntax error also. This is a mathematical operation problem. We have a 2++ instead of a single plus, right? And you can't do this in math. It's not a legal math operator unless you attach it to the 23 or to the 10. Then maybe a little bit different, or you still get an error. But so that's a syntax error because you're not following the rule. That's what the syntax means, right? So each language has their own rules, and you should have to write code to conform to those rules. And when you violate those rules, you get a syntax error. Okay? So the syntax. The second one is the runtime errors. This is about a medium level because runtime can also be the cause of a syntax error. which is not run yet, right? It's not, maybe the syntax error is embedded inside a function which has not been executed yet, so that line has not been run yet. But when you run it, the code will still run until you call the function, and inside the function you have a syntax error, and then that will trigger the error. It will cause the system to crash. So that is still part of the runtime because it happens when you actually running the system, the program already, right? So it's caused by a syntax error, but it is a runtime error. Okay, so runtime means any time that causes your system to crash when the system is running. That's what we call it, runtime. So like things like a file is not found, you can't write to a disk, and you run out of memory, right? Run out of resources. All those are caused as a runtime error. Okay. Another one is like I just mentioned here, right? So for example, maybe you haven't declared or defined this function called handle click, or maybe you mistyped it. But again, it doesn't happen until you run it, right? So when you run, you click the button, only at that time, then it will call that function and then it will generate the error. So it is a syntax error, but then it only happens when you click on it, so therefore it's a runtime error, okay, during runtime, okay? And the nice thing about these, a modern or a robust IDE is that they will tell you the syntax. As you type, you can see that it has a red squiggly lines underneath it, or has a red mark on the edge of that. That screen tells you all those errors, so you can fix them before you run them, which is kind of nice. It saves you a lot of time. If you don't have that type of IDEs, if you were to use something like very plain, like a Notepad or Notepad++, for example, you won't see those until you run it, and then you'll see the code, but how many errors, but those will consume a lot of your time. Okay, so another one here is a runtime error is you have an undeclared variable, right? You want to write the message out, but then the message has not been declared, so therefore you have a undeclared variable, and that will also terminate your code. Okay. So I just mentioned again here is an example we were caused by syntax error because the message here is not defined. So it's embedded inside a function, but since we haven't called it yet, so we're not going to get this error until we actually click the button, and then you'll find that the message is not defined. Okay, so you get the error. The logic error, this is again the most difficult one. A logic refers to the order in which your code executes. So sometimes where you place your code is really important, right? Some things have to happen first before the other things can occur. So when you run out of order like that, you can generate some really weird results. Okay, that's one of them. Another is you have different type of data that you not expect, and then you get a completely different result, or maybe you put in a wrong number or wrong entry, and then that data will get either multiplied or concatenated or something with that calculation, and you get a really weird result. So for example, here you have a 10 times 2, but your output says divided by 2, and you get a different result. So either you mistyped here, this should be a division, or this should be a multiplication, right? So either way, but this is something that would can cause you headaches. Okay, it doesn't tell you exactly what the error is. If you have a really short code, like maybe 10 lines, it's not easy to find. But imagine you have, let's say 10 scripts, and they all call each other, right? Where do you find that error? So, if you are the programmer yourself, you kind of know what things are. But if you give that to somebody else, then they have to trace the entire script to find out where that error is. So it's really hard to detect. A very common one, I'm sure if you have not gone through this before, you will one day, going through infinite loop. Okay, especially very common in using a while loop or a do loop. Okay, because you always have to either increment your counter, or you have to do something to cause the condition to be false to exit out of the loop, right? If you don't do that, then you run into an infinite loop, and that is caused by a logic error. So here, for example, this will be an error because this count never gets incremented. Okay, it always stays at 10, and so therefore the loop will go forever. Okay, it's an infinite loop. So because you don't put the plus plus here, right? So you never get incremented. So therefore, will always be greater than or equal to 0. In this case, it will maybe like a minus minus to decrease the counter to 0. Okay, so that's another example. And again, don't run it unless you want to close your browser and then restart, right? Some browsers will let you terminate. Like I think Firefox might let you do that. If you run this on Chrome, you have to really shut down the Chrome browser, not just the window, to shut down the entire browser because it will stay in the cache. Okay, so not a nice thing to do. Here's another error, right? The assignment versus the equality. That's this guy right here. You might have seen this before. So if you do something like this, if magic is equal to 3, you would think, okay, what you're doing is actually you're assigning the value of 3 to magic, and that can be done, and that will always be true in this case. And so the code will run, okay? Even though if you enter a number of 10, it asks you to enter a number, you put 10 in there, and it's still going to run this code because, yeah, magic will be assigned to the value of 3, okay? So just be careful with the equal sign and the double equal sign. All right, so we have those kind of bugs, and there must be ways for you to fix them. Okay, so you want to be a smart programmer. Okay, you want to write your code, make it so that you follow a certain rule, certain style. You use your line numbers to show you what those, so you can see the information. Not only that, I'm going to skip this. This is just information about the errors. Okay, use good syntax. This is really good. Make that a habit. Okay, if you always put curly braces for every block of code, then do it. Okay, even if your if statement has only one sentence or one line of code, if that's a habit, then make that a habit. It's always safer to do that. Okay, so I think if you do really good with that, have a really good syntax, follow a really good system, then you will pretty much save yourself a lot of time from debugging. Okay, if you have a really messy code, not indenting your code indentation is really important as well. If you learn Python, you see that is required. Okay, because Python doesn't have the parent. I mean the curly braces, and so the way Python works is the indentation number, right? If you have the exact indent spaces to make the code work, if you put one indentation more or less, then you will have an error. So that's Python, but so write good syntax. Okay, if you are used to capitalize your variables, then do that. Don't mix between the two because again, it just look messy, right? So follow a system. Test on every browser if you are writing JavaScript for a project you're doing, right? Chances are you're going to have to deal with 3 major browsers. You know what those are already, IE and Firefox and Chrome, and Opera is coming popular too. So make sure they run not only just different browser, but different browser version too, right? So if you write a site, if it's a government site, you also will have to write to make sure your code will actually comply with the the ADA. Make sure your screen readers can read them. Apply to like the deaf and the blinds and so on. So you have all those things to consider as well. When you trace the errors, you can use the window alert to do that. Okay, it's annoying, but it helps sometimes. So when you trace your code, you can say, you know what, I'm on line 10 now. I'm going to put a window alert here so I know that this line's from top to bottom or whatever that is being called. It works fine. So you put that message there. And then if you go into the function, put another alert there. I'm just say inside the calculate some function now. Put that message there so you can see that it's working. Okay, either if it's never get called or it's not running, and you expect that function to be called, it's not showing up, then something's wrong, right? So they have to be reached. And again, the downside is just it's really annoying to see the pop-up window every time. So instead of doing that, you could also use the console log, right, to display the data to the console instead. And when you trace it, you just turn on the console and you'll see the messages there as well. When you put the messages, though, I mean, be as descriptive as you can. Don't just say A or B or C, right? Just say where you're at, line 25. Put the line number, where your code is. You can say line 25, inside function calculate, right? At line 45, do something like that. So you know exactly, because when the error occurs, it's going to tell you the line number with it too. Another method is to comment out your code. A piece of code that is not running, well, it's running, and you expect that to run or not run, comment it out and see what happens, right? Turn that off. You turn it off, and you can, in its place, just put another message there, right? So don't run the code. And if it runs through that piece of code, then maybe something's wrong with that block of code. Okay, so kind of like narrow it down. Try to use this method called the divide and conquer to narrow down the bug. Okay. You can use the debugging tools. Okay, we use that many times in this class, since probably like day 1 or day 2. And most browsers have it. You just press the F12 key and it will tell you. So here is, again, this is borrowed from the book. I'll show you how for those 3 browsers you can press these keys to get them. One thing I wanted you can use is just if you have an array. Okay, if you want to display the values of the array, you could just, let's just say you have a array of these numbers, and then if you want to print this out, you can put console log. Will give you an array of those numbers. It may not be displayed in a really nice way. You can expand it, you can see it, but another option you can use is uses console.table, and some browsers you will have to put the square brackets. So inside the square brackets, you put the name of the array, and it will print this out for you. It will look something like this. It will be really nice. Give the index number along with the actual values too. So it's really, really useful just for visual. Again, only works for arrays. It does not work for like a string or anything like that. Okay, so I think it does work for objects too, but a little bit tricky. But if you have an array, we use the contact console.table. I'm not sure if it works on every browser, but I think Firefox and Chrome do have them. Okay. To set up breakpoints, well, we'll do this in a minute. This is how you can trace your code. You can set some breakpoints, and when your execution starts to that and reaches that line number, whatever that is, then you can actually, the program will pause there, right? It will pause, it will stop there, and you can manually go through the code line by line, follow how the code are being executed, and it will tell you some information about your code. Okay, we'll do some example of this tonight. Just show you here from the book again. So you can set and declare the breakpoints. You can step through or do that through your scripts. And stepping in, stepping out, or over. And you're tracing your variables. That means you can actually put that into like a watch list and look at your variables and see their current state, what data they have. Okay, whether they have any data or not, you can tell. And that's another really cool way to help you debug your code. Okay. The call stack here is okay. I mean, it's not. I would say. I mean, I don't really use it, but if you have to, you can. This is not as nice as the call stack in Java. Okay, it's like in Java, if you run your script, your code, if you have an error, it has a call stack. It tells you every function that's being called, where it's called from, and it will trace all the way to the origin of where that was being called from. So if you have like 3 functions or 4 functions, and the error is in the fifth function, it will tell you the list where it's being called from, so you can trace back. So you have that's a call stack. Okay. And then we also have this option available in the WebStorm. Okay, most IDEs, I mean like the more robust IDEs like WebStorm, Visual Studio, and I think Brackets too. You can have they have a debugger built into it. You can use them, and I'll show you with WebStorm. And here are just some exception handling statements. The again, exception is the common term for the error. You have what's called a throw statement. The throw will actually force an error to occur, so that, again, just for debugging purposes. Okay, you just write the word throw and then followed by a phrase or anything you want to put over here, basically a phrase, or you can call another function to do something else, but it will throw that error. And then this error, if you just use it by itself in your code, then execution will stop there and it will throw that error message to the console. You'll see that in the console. Again, this is only for debugging, so you don't want to do that on the live side. Okay, so you throw that out there, and then it will throw the message out there. If you put that inside a catch, then usually the catch, this message here, whatever this error is, the value over here on the right side, will be stored inside a global object called error in the error constructor, and then in there you can access it through the catch statement. Okay, so we have a try catch. It's a very common block of code that allows you to test your code. So usually have the try catch and finally blocks. It's common through most languages. I think probably all of them. Okay, so the idea is that you want to try this code in here and make sure that it works. It doesn't generate any errors. If it does have an error, then that statement will stop, or wherever that error is, the line of error is, it will stop execution at that point, and it will jump down to the catch statement, and then it will continue from there on. And the catch is really, it will catch the error, whatever the error is. And it will pass that error into a variable you put in here. Here, just use E. It could be anything. It's just a variable name. Okay. So, for example, if I throw an error called error 2, then if I put that in here, if I say error 2, throw error 2, then it will force that statement to jump over to the catch area, and then the error 2 will be stored inside this variable called E. Again, it could be anything you want, any legal variable name, and then you can display the error message to either the user or to yourself, right? So we have the try catch finally. Now, the try and the catch and the finally here, they cannot be used by themselves. Okay, they have to come with a pair. You cannot use like catch and finally by themselves either. Okay, either have to be a try with the catch, try with the finally, or try with catch finally, in that order. Okay, you cannot put like try finally and then catch either. That's what, again, it's just a rule, right? So if you want to try something like this, you can say you try these statements in here. If there are no errors, good. Then you will bypass the catch part and continue execution after the catch. If there is an error in that statement, then it will jump into the catch. Okay. I put a message here. I think, okay, unlike these languages, you can only have one catch phrase or catch statement. As you can see in Java and C++ and all these other languages, you can have multiple catch statements in there because you have different types of errors. You might have like a division by 0. You have a out of index range, out of index. You have file not found, or you can't open file. So all those are different type of exceptions. You can catch each of those individually. So you can have multiple catch statements here. But in JavaScript, it's only one. Okay. And here we have or you can try the try and finally, right? And you skip the catch. The only thing with it finally here is just like any other try and catch, that part of the statement will always run regardless of whether there's error or not. Okay, so it's like a catch-all. If you remember your case statements, right? You have switch and then case, and you have the default at the end. So that's a catch-all. But the difference is this will run regardless of what the conditions up here. Okay, whether there are any errors or not, it will always run. And you usually use this for like maybe to reset some type of values, or output some kind of statements, or maybe on the back end you could maybe reset or rewrite data to your file, because JavaScript now can be used on the server side, right? With Node.js, you could access data on that end, but on the front end you can't. So usually you'll use for those kind of purpose. So here again, the full try catch finally. Okay, and the reason why you want to use try, you might ask, so when do you use try or catch, right? This is useful for when you want to read any type of input, because you might get the wrong input. So instead of having your site crash, you want to put a try in there and then catch it if it's an error, and you put a really nice message to the user so they don't freak out, right? Suddenly just like boom, your site crashes and it's just like I don't know, shuts down or something. They just like they will leave your site usually. They think it's hacked, right? So you want to be nice to them. So only again use it when you want to test for some type of input, especially from a web form, right? You will read the form, or if you are reading that from, let's say, an AJAX file, reading from a cross server, anything to do with that, or if you're expecting that maybe the array or some sort might have some invalid data, right? You will validate those, so you will use that. Otherwise, you don't need to do it, okay? So here's an example of that. If you were to try, if you were to run this code, for example, you alert hello world, whatever it is, and that will give you an error. And then the error here will be passed to a variable we call error here. You can call it E, and you can log that, print that out, and you will see that it's a syntax error. It will tell you that because you cannot put or you can, but you have a a double quotes here, and then you have a unmatched quotation marks. Okay, that's all. So you will see something like unexpected token or wrong token. That means you have one of these characters is not compatible or is incorrect. So in this case, it doesn't match up. Okay. And just to show you that this line will be ignored. Anything that occurs after the error line that throws the error, for example, I just basically explicitly force an error to say oops, right? And you throw an error. That's where the execution stops at that point for that block of code, and then we'll jump to the catch down here. And then this error message here will be passed to the error variable here, and you can print that out. And then by doing that, every statements below this line will be ignored. Okay? So just beware of that. Okay, I think that's pretty much I wanted to talk about. Again, feel free to reread it and then read it some more if you need to.